the perhaps final frontier that I think is worthy of mentioning, the next step in this evolution of process optimization is xRoutines. They have different names. The two that come to mind are Goroutines, which are very specific. They're specific to Golang. And then coroutines, which depending on the implementation that you're talking about, is basically a Goroutine, or it's basically a green thread. Green threads do not solve our problem. Goroutines do solve our problem. So certain types of coroutines do solve our problem. These types of things are only 4 kilobytes each, so they pretty much scale infinitely. All other resources on the computer will become exhausted before the RAM for these becomes exhausted. And they are basically the difference between the way, they use event loops as well. So, you know, everything progresses. Threads use processes. Event loops use threads. Goroutines, coroutines use event loops. So everything is just a natural progression of we need to make it better, we need to make it better, we need to make it better. So these Goroutines and coroutines, they're basically all worker threads. But they can be thought of, they kind of like unreferenced threads are special in Node. Both the main job, because the main job is just a job on the task queue, just like any other job on the task queue. It's not even a thread. It's just a job that goes on a thread. But the main job or the main task is slightly special. And there are also sleepers. So in Node, the way that we handle asynchrony is we have things like promises and callbacks and async await. When you have Goroutines and coroutines, one of the things that people like about them is that you don't have to have a concept of promises or callbacks. You can, because there are in fact transpilers for coroutines and Node, which are not the type of coroutines that we're talking about, because anything that transpiles to Node can't be using true Goroutine style coroutines because they're limited to the main thread. So even though you can implement a language that looks like it takes advantage of it, if you transpile it to Node, it can't take full advantage of it. But anyway, languages that have this type of thing, they can have callbacks and they can have promises and they can have async await, and some of them do, but they're not necessary. Because a sleeper is when a job gets to a task that requires waiting, it becomes a sleeping job. And a sleeping job basically jumps out of its thread. It gets pulled from its thread and put back into the event loop. And then very much like we just described of a completed process being pulled out of the event loop to the main thread, in the case of this style of programming, the job itself can be taken on and off of a thread with the event loop. And that includes the main job as well as any worker jobs. And so when a job can't do something, it just gets offloaded from its thread and put back onto one of the event loops, because these may be running multiple event loops because they are like that. And then of course you have the job queue. So I don't have good examples for this. Unfortunately, that's the end of the presentation, but Golang is kind of the primary example of a very easy to use language that implements this style of event queuing. And it does have What it does introduce, though, if you don't do it in a functional way, if you use, like, Go is not a pure functional language, you do get back into this problem, because Goroutines and coroutines can have data races. Now, languages that have, Rust doesn't have the Goroutine equivalent per se, but between the way that it can have channels and it can have, it has its own version of promises called futures. The way that Go and Rust, if you program them correctly, you don't get into data races, because you use, in Go you use channels, or in Rust you use futures, and it allows you to avoid this problem. But it is possible to write naive code that ends up with that same problem where something changes out from underneath you. So there may be yet something after these xRoutines that would probably be implemented in a language that is almost pure functional, that would solve the data race problem for us as well. But as far as I know, that type of event loop does not exist yet. And that is all that I know about event loops and why we have them, and the kind of the history that led to us getting to them, and that core problem of race conditions being why Node is still popular than, well, aside from that JavaScript is the only language you could have in the browser and is a relatively easy language to pick up. So it's got just a lot of drive behind it. But why Node is still vastly more popular than languages like Golang or Rust that do implement these xRoutines, because those languages have a little bit more that you have to know in order to use those things appropriately without more harsh failures.